Now we will move on to our next example, which is the derivative of cosecant of x using the limit definition of the derivative. We want to evaluate the derivative of cosecant of x. So our f of x is equal to cosecant of x. Our f of x plus h, wherever you substitute in, we substitute in x plus h wherever it is that we see x. So this will become cosecant of x plus h. And we're going to need the addition of sines formula later on, so let's go and write it down. Sine of x plus h is equal to sine of x multiplied by cosine of h plus sine of h times cosine of x. So we want to take the limit as h approaches 0 for f of x plus h minus f of x all over h. So our f of x plus h will be cosecant of x plus h. So we'll take the limit as h approaches 0 for cosecant of x plus h minus cosecant of x divided by h. And I remind you that cosecant of x is simply the inverse of sine, so we can rewrite this just as we did in the previous problem with secant. We can rewrite this as 1 over sine. So this will become the limit as h approaches 0 for 1 over sine of x plus h minus 1 over sine of x all over h. So what we want to do here is get these under a common fraction just as we did in the secant example. So we want to take the limit as h approaches 0. We'll multiply this by sine and this by sine of x plus h. This will become sine of x minus sine of x plus h all over sine of x plus h times sine of x. All of this divided by h. Now we can drag this into the denominator. So we'll take the limit as h approaches 0 for sine of x minus sine of x plus h divided by h times sine of x plus h times sine of x. So now what we want to do is we want to substitute, just as we did in the previous example for sine of x plus h, we will substitute that in for the addition of sines formula. So let's make some room. We want to substitute that in for that, so we'll take the limit as h approaches 0 for sine of x minus sine of x plus h, which we will open our brackets, sine of x times cosine of h plus sine of h cosine of x. Now let's go and drop our brackets and distribute the negative sign. So this will simply become negative sine of x. This negative sign will also be distributed here. All of this divided by h multiplied by sine of x plus h multiplied by sine of x. Now what we want to do is we want to split this up into different limits, just as we did in the secant example. So let's erase this. And we want to factor a sine of x out. So let's join these terms over here into one limit and then make whatever's left over a different limit. So we'll take the limit as h approaches 0 for sine of x minus sine of x cosine of h over h multiplied by sine of x plus h times sine of x. And let's erase this. And we will have whatever is left over, which will be minus the limit as h approaches 0 for sine of h cosine of x over h multiplied by sine of x plus h times sine of x. So what we can do here is we can factor a sine of x out. So limit as h approaches 0 for sine of x multiplied by 1 minus cosine of h over h multiplied by sine of x plus h times sine of x. And we know very well by now that the limit as h approaches 0 for 1 minus cosine of h over h goes straight to 0. So here we have common factors of 1 minus cosine of h over h. That means that this entire limit will go straight to 0. So all we'll be left with is this negative limit right over here, where we'll take the limit as h approaches 0 for sine of h times cosine of x over h times sine of x plus h times sine of x. And another limit that we should know very well by now is the limit as h approaches 0 for sine of h over h goes straight to 1. So we can circle these, cross them out, this becomes 1. So all we'll be left with is the limit as h approaches 0 for cosine of x over sine of x plus h times sine of x. And just as we did in the previous example with the secant, we will let h approach 0. So we will be left with cosine of x in the numerator and then sine of x multiplied by itself in the denominator. So what we have left is, forgot that there's a negative sign right out here in front of this limit. We will be left with negative cosine of x over sine squared of x. So we will split this up. Let's write this out as negative 1 over sine of x multiplied by cosine of x over sine of x. Negative 1 over sine of x is simply negative cosecant of x. So this becomes negative cosecant of x. And this, cosine over sine, becomes cotangent of x. So the derivative of cosecant of x is negative cosecant of x cotangent of x, using the limit definition of the derivative.